It's your boy, Dr. Alexander. I'm here to talk to you all about Lewis structures. So there are some things I want to tell you. Basically, I want you to take heed to in the very beginning of this video. One, electronegativity. Basically, the center of the center element or the center atom that you're going to use for your Lewis structure has to be the least electronegative, the octet rule. Basically, what I'm trying to tell you with the octet rule is that every single element around that's inside every element should have at least 8 valence electrons around it, except hydrogen. We don't care. We don't worry about hydrogen. Hydrogen doesn't matter in this world. And like I said, hydrogen is never in the center, and it does not receive any valence electrons. Those are some rules that I think that are really going to help you learn and be better at drawing Lewis structures. So I picked out 2 of my favorite Lewis structures, and I'll go over how to draw them with you all today. So one of my favorite Lewis structure is silicon dioxide. Basically, for silicon dioxide, the silicon element has 4 valence electrons, and the oxygen element has 6 valence electrons, but since there are 2 of them, we're going to multiply that 6 by 2. We're just going to add the 6, and so 6 plus 6. So we're going to have 4 plus 6 plus 6, which is going to turn out to be 16. So first thing we want to do, we want to find out the atom, which atom is the least electronegativity, is the least electronegative, and that will actually be the silicon. The oxygen electronegativity is 3.5, and the silicon is 2.5. So we're going to send that in the middle, and then we're going to put the oxygen around it, 1 and 1 right here. So now we have 16 right here. So basically, if I were to draw it, we have to connect them immediately. So this is 2 electrons and this is 2 electrons. Each line equals 2. So we're going to subtract 4 from here. That'll leave us with a total of 12. What we do from then is we actually disperse the electron. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You always want to disperse it to the outer shells of the thing, and you want to work the outer shells of the compound, and then you want to work your way in. Now we notice that this is surrounded by 8 valence electrons. This is surrounded by 8 valence electrons, but the silicon is not. It's surrounded by 4. So an easy fix will absolutely be to just simply erase these and erase these right here, and then draw a line right here and draw a line right here. Now these are surrounded with 8 valence electrons. This is surrounded with 8 valence electrons, and this oxygen on this side is surrounded with 8 valence electrons. It actually helps you move a little better. All right, so now I have to do another one. So hopefully you all got that screenshot if you haven't. Now to this other one. I'm going to actually draw out. I'm feeling like drawing out saline. The compound formula for saline is Si H4. So there's one Si atom, and Si has approximately four atoms. And then if you can see, hydrogen has 1 atom. So we have 4. We have 4 of those, so 1 plus 1 plus 1 plus 1. So that's going to equal out to about 4. So we're going to have 4 plus 4. That is the total amount of electrons. We have 8 electrons right here. So if I were to draw this, I have the Si right here, and these 4 electrons. And like I said, hydrogen is never ever going to be placed in the middle. Okay, so let's see. We got to bond them all to the silicon atom. So we have 2, 4, 6, and 8. Boom. Now you notice some may question, why is it that the hydrogens are not obeying the octet rule? Hydrogens are the only atoms that do not have to obey the octet rule, and this is how you would do this right here. We will actually name this type of We'll actually name the electron geometry of this, and this is a little further up in your course. Tetrahedral. Okay. How many minutes are we in right now?
5 minutes.
Okay, that's it.